Hello, listeners. This is Mike, your host. If you are enjoying these archive episodes, please consider supporting the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Hopefully, with your support, I can continue to release these archive episodes. Thanks.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
I feel okay, I'm on.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Listen, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 136 of the Space Rocket History Podcast. And now, Apollo 1, What Went Wrong?
If ever we needed a rededication to this program and a repointing out of the importance of little things and a repointing out of the attention to detail that's required, then this event brings it home. The problem is that we just weren't quite good enough, but we will be the next time we come up.
That was Joseph Shea speaking to his team 3 days after the Apollo 1 accident. What went wrong? Even years after the investigators began to sift through the wreckage of Apollo 1 piece by piece, no one could say exactly. But within weeks, the general picture became clear. The fire was a disaster waiting to happen. As the investigation proceeded, information began to be released. About a month after the fire, Miller admitted to Congress that after 6 safe years of manned flight experience, it was now obvious that NASA's approach to fire prevention had been wrong. Minimizing the possibility of ignition had not been enough. Safeguards against the spreading of any fire must also be developed. Since it would be nearly impossible to design equipment that would protect the crew, both on the ground and in space, any non-metallic and perhaps flammable materials would have to be carefully screened. In particular, the 4 F's required further investigation. The 4 F's are fabric, fasteners, film, and foams. Also, wiring, plumbing, and packaging would be reevaluated, even if it meant reviving the old debate about a 1 versus 2 gas environmental control system. On February 25th, Siemens prepared a memorandum for Webb listing early recommendations by the Thompson Board that the administrator could present to Congress. The recommendations were as follows. 1. That combustible materials now used must be replaced wherever possible with non-flammable materials. 2. Non-metallic materials that are used must be arranged to maintain fire breaks. 3. Systems for oxygen or liquid combustibles must be made fire resistant, and that full flammability tests must be conducted with a mock-up of the new configuration. 4. A more rapid and more easily operated hatch must be designed and installed. And 5. On the pad, emergency procedures must be revised to recognize the possibility of cabin fire. During the investigation, much emphasis was placed on how the astronauts felt about the safety of the Apollo program. The astronaut member of the Thompson Board, Frank Borman, assured NASA's top officials that he would not have been afraid to enter the Grissom Cruise spacecraft that January day. Working with the board, however, Borman and everyone else had come to realize the substantial hazards that had been present but not recognized before the fire. Here's a clip of Frank Borman.
There's no question about it. We all overlooked the fact that it was a coffin, and I would have flown it gladly. I think that the outlook of people that remain is very similar to the outlook of anybody in the Air Force or anyone that's been involved in hazardous duty. There's a certain defense mechanism where you firmly believe that it's never happened to you, and when it happens to somebody else, you just press on.
As the Thompson board finalized its report, they recognized that there had been ignorance, sloth, and carelessness. But the key word in all the detailed information was oversight. No one, it seemed, realized the extent of the fire hazards in an overpressurized, oxygen-filled spacecraft cabin on the ground. According to the summary report the board issued on April, which said, quote, although the board was not able to determine conclusively the specific initiator of the Apollo 204 fire, it has identified the conditions which led to the disaster. 1. A sealed cabin pressurized with an oxygen atmosphere. 2. An extensive distribution of combustible materials in the cabin. 3. Vulnerable wire carrying spacecraft power. 4. Vulnerable plumbing carrying a combustible and corrosive coolant. 5. Inadequate provisions for the crew to escape. And 6. Inadequate provisions for rescue or medical assistance. End quote. Having identified the conditions that led to the disaster, the board addressed itself to the question of how these conditions came to exist. Quoting from the report again, careful consideration of this question leads the board to the conclusion that in its devotion to the many difficult problems of space travel, the Apollo team failed to give adequate attention to certain mundane but equally vital questions of crew safety. The board investigation revealed many deficiencies in design and engineering, manufacture, and quality control. End quote. The Thompson board report was almost 3,000 pages long. It was divided into 14 booklets. It made a stack almost 20 centimeters high. As the hearings progressed, they began to delve deeper into the reasons behind the tragedy. NASA officials were confronted by some skeletons in the closet. Senator Mondale raised the question of negligence on the part of management and North American by introducing the Phillips Report of 1965. The implication was that NASA had been thinking of replacing North American. But these charges were vague, and for the next several weeks, no one seemed to know exactly what the Phillips Report was. Senator Mondale also alluded to a document called the Barron Report, written by a North American employee, Thomas R. Barron. The report was critical of the contractor's operations at the Cape. But, as I said last week, Mr. Barron and his report were discredited. Representative Margaret Smith of Maine wanted to know exactly how North American had gotten the contract in the first place. Webb told her that an independent 200-man technical panel had made the selection. But new documents leaked to the press showed the Martin Company had actually scored the highest on the original technical evaluation, and North American was the second by 0.3 of a point. As you may recall from a previous episode, Webb and his colleagues had in fact overruled their own evaluators when they gave the contract to North American. Administrator Webb was now forced to admit that his previous statement about the selection of North American was not entirely accurate. Beyond the Phillips and Barron's reports and the selection process of North American, the recollections of events and warnings during the past 6 years made each Apollo manager wonder if he had really done all in his power to prevent the tragedy. In March 1965, for instance, Joe Shea and the crew systems people in Houston had wrestled with the question of one or two gas atmosphere and the likelihood of fire. Most of the studies were admittedly based on the possibility of fire in space and concluded that a pure oxygen system was safer, less complicated, and lighter in weight. Also, they decided the best way to guard against fire was to keep flammable materials out of the cabin. But Hilliard W. Page of General Electric had, as a matter of fact, warned Shea about the likelihood of spacecraft fires on the ground as recently as September 1966, and just 3 weeks before the accident, Medical Director Charles Berry had complained that it was certainly harder to eliminate hazardous materials from the Apollo spacecraft than it had been in either Mercury or Gemini. Although the Senate committee had begun its hearings while the board investigation was in progress, the House subcommittee waited until the final report was ready. By then, the Senate had touched on most of the major issues. As expected, the exact cause of the fire in Spacecraft 12 was never determined, but the analysis of all possibilities led to specific corrective actions that eventually satisfied Congress. Throughout the hearings, astronaut Frank Borman, still wearing two hats, one as an astronaut and the other as a member of the Apollo 204 Review Board, was very effective. In the course of his testimony, Borman reiterated that the cause of the fire was oversight rather than negligence or overconfidence. Fire in flight, he said, had been a matter of grave concern since the early days of aviation and the subject of numerous studies. But the notion that a fire hazard was increased on the ground by the use of flammable materials and an overpressure of pure oxygen had never been seriously considered. During the hearings, astronauts Wally Schirra, Deke Slayton, Alan Shepard, and James McDivitt were questioned, and they expressed their confidence in NASA's future safety measures. Here's a clip of Wally Schirra.
I would say that on January 27th, at the time I landed in Houston, I lost all confidence. And that's only natural. We suffered a very grievous accident from something we thought wouldn't happen. Now, from that point on, we've had many different tests performed on flammability of materials. We've discovered that many of the materials must be changed. When these are changed and when tests are completed on the new materials, our confidence is restored.
And Frank Borman answered a congressman's doubts by saying, quote, "You are asking us, do we have confidence in the spacecraft, NASA management, our own training, and our leaders? I'm almost embarrassed because our answers appear to be a party line. Everything I said last week has been repeated by the people I see here today. The response we have given is the same because it is the truth. We're trying to tell you that we are confident in our management and in our engineering and in ourselves. I think the question really is, are you confident in us?" End quote. When Borman made a plea on April 17th to stop the witch hunt and get on with Apollo, both NASA and North American had responded to the criticisms of the Thompson Board and of Congress. As a result of the investigation and hearings, top-level personnel changes were made. Everett E. Christensen at NASA headquarters resigned as Apollo mission director. George Lowe replaced Joe Shea as Apollo spacecraft program manager in Houston. At North American, William Bergen, formerly of the Martin Company, took over from Harrison Storms as president of North American Space and Information Systems Division. Storms was moved to the Brickyard. He was still a company vice president, but he just had a staff job. Bergen, his replacement, brought with him 2 associates from Martin, Baston Hello to run the Florida facility for North American, and John P. Healy to manage the first manned Block II command module at Downey. Healy was expected to set precedents in guiding a nearly perfect spacecraft through the factory. Most North American officials weathered congressional criticism and pointed out that they agreed in part with the formal findings and recommendations of the Thompson Board. But North American objected to the word chronic in describing the problems with the environmental control system and defended its electrical wiring practices as functional rather than beautiful, concurring that the fire probably started from an electrical spark somewhere near the environmental unit. The manufacturers also agreed with NASA on why the fire spread, the reason being that the attention was principally directed to individual testing of material. What was not fully understood by either North American or NASA was the importance of considering the fire potential of combustibles in a system of all materials taken together in the position which they would occupy in a spacecraft and in the environment of the spacecraft. With the hearings nearly finished, on May 9th, Webb was again called on the carpet by the Senate committee. The Phillips report was again a major subject for debate, this time in a context that made it appear that the NASA and North American relationship was in danger of becoming a political football. The very next day, however, congressional questioning began to wind down, as Congressman John W. Wilder put it, quote, "Essentially, the story of the Apollo accident is known to the American people. We have admissions and statements about the things that NASA and North American aviation were doing wrong. But I want to say to you, Mr. Webb, over the past few years, I probably have been one of the most critical members on this committee of NASA. It appeared to me that you have had it too easy for your own good from this committee. This is not a criticism directed at you or the space agency, but a criticism being directed inwardly at the Congress and this committee. I feel right now that you have got less criticism than you deserved in the past, but now you're getting more criticism than you deserve. I don't intend to add to it for that reason." End quote. Wilder did not really stop there, of course, but the investigation did begin to fade away. NASA and North American began implementing the technical recommendations. To some degree, the accident actually bought time for some pieces of Apollo, the lunar module, the Saturn V, the guidance navigation system, the computers, and the mission simulators to catch up with and become adapted to the total configuration. Now that the investigations and hearings are finished, I want to cover exactly what happened on January 27, 1967. The following is the chronology of the fire based on the investigation. This is how the board believed the fire began and progressed. All times given are Eastern Standard Time, PM. The investigation showed that it was most likely that the fire began in the lower forward portion of the left equipment bay to the left of the command pilot and considerably below the level of the couch. Now the timeline begins. At 6:30 and 50 seconds, variation in signal output from the gas chromatograph was detected. At 6:30 and 54 seconds, a significant voltage transient was recorded. At 6:30 and 59 seconds, the oxygen flow rate reached the limit of the sensor. At 6:31 and 0 seconds, movement in the spacecraft was detected. At 6:31 and 5 seconds, the first verbal indication of fire was reported by the crew. It sounded like, "Fire! We've got a fire in the cockpit." Once initiated, the fire burned in 3 stages. The first stage, with its associated rapid temperature rise and increasing cabin pressure, terminated 15 seconds after the verbal report of the fire. At 6:31 and 12 seconds, the fire became intense. The slow rate of buildup of the fire during the early portion of the first stage was consistent with the opinion that ignition occurred in a zone containing little combustible material. The slow rise of pressure could also have resulted from absorption of most of the heat by the aluminum structure of the command module. At this time, the fire had broken from its point of origin. A wall of flames extended along the left wall of the module, preventing the command pilot occupying the left couch from reaching the valve that would vent the command module to the outside atmosphere. But opening the vent valve would have been to no avail because the venting capacity was insufficient to prevent the rapid buildup of pressure due to the fire. It was estimated that opening the valve would have delayed command module rupture by less than 1 second. At 6:31 and 16 seconds, cabin pressure exceeded the range of the transducers. At 6:31 and 17 seconds, the final crew communication began. The entire transmission was garbled, and it ended with a cry of pain. At 6:31 and 19 seconds, the command module cabin ruptured. The command module was designed to withstand an internal pressure of approximately 13 pounds per square inch above external pressure without rupturing. Data recorded during the fire showed that this design criteria was exceeded late in the first stage of the fire. The point of the rupture was where the floor or aft bulkhead of the command module joined the wall, essentially opposite the point of origin of the fire. The original flames on the left wall now rose vertically and then spread out across the cabin ceiling. The debris traps, made of nylon netting, provided not only combustible material and a path for the spread of flames, but also firebrands of burning molten nylon. The scattering of these firebrands contributed to the spread of the flames. At the same time, Velcro strips positioned near the ignition point also burned. The rupture of the command module marked the beginning of the brief second stage of the fire. This stage was characterized by the period of greatest conflagration due to the forced convection that resulted from the outrush of gases through the rupture in the pressure vessel. The swirling flow scattered firebrands throughout the crew compartment, spreading the fire. At 6:31 and 22 seconds, the crew's final transmission ended, about 17 seconds after their first report of a fire. Then, loss of telemetry. Telemetry loss made determination of precise times of subsequent occurrences impossible. At 6:31 and 25 seconds, the second stage of the fire ended. Evidence that the fire spread from the left side of the command module toward the rupture area was found on subsequent examination of the module and crew suits. Evidence of the intensity of the fire included burst and burned aluminum tubes in the oxygen and coolant system at floor level. At 6:31 and 25 seconds, the third stage of the fire began. It was characterized by a rapid production of high concentrations of carbon monoxide, following the loss of pressure in the command module, and with fire now throughout the crew compartment, the remaining atmosphere quickly became deficient in oxygen, so that it could not support continued combustion. Unlike the earlier stages where the flame was relatively smokeless, heavy smoke now formed and large amounts of soot were deposited on most spacecraft interior surfaces as they cooled. The third stage of the fire could not have lasted more than a few seconds because of the rapid depletion of oxygen. It was estimated that the command module atmosphere was lethal by 6:31 and 30 seconds, 5 seconds after the start of the third stage of the fire. Although most of the fire inside the cabin module was quickly extinguished because of a lack of oxygen, a localized, intense fire lingered in the area of the Environmental Control Unit. This unit was located in the left equipment bay, near the point where the fire was believed to have started. Failed oxygen and water glycol lines in the area continued to supply oxygen and fuel to support the localized fire that melted the aft bulkhead and burned adjacent portions of the inner surface of the command module heat shield. The major concern during all this, of course, was the crew. People wanted to know exactly what caused their death and if they had to suffer much. By the time the hull ruptured, the horror of being trapped in an inferno was nearly over for the crew. Seconds later, their oxygen hoses burned through and carbon monoxide forced its way into their spacesuits. The medical examiners estimated that 15 to 30 seconds after that, the men lost consciousness. Within 4 minutes, there was no hope of reviving them. But the crew did not burn to death. They were asphyxiated. Now I have a clip of Chris Kraft recorded in 2009 commenting on that terrible day.
Many of these people had never had any experience in space flight. They came from all kinds of other engineering walks of life. But they had been given the task to very quickly come up to speed and start building a spacecraft. And frankly, they built a damn lousy spacecraft. They were running like the devil, trying to get it done. They didn't have time to listen to lessons learned. And it was quite a turmoil in 1967 when we sent 3 men to their death on a pad at Cape Canaveral. It was a terrible day, a very terrible day to watch that happen.
Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.